students, I am going to discuss a problem of wave motion. The problem is, figure shows a snapshot of a vibrating string at t is equal to 0. The particle P is observed moving up with a velocity 20 root 3 centimeter per second. The tangent P makes an angle 60 degree with the x-axis. Find the direction in which the wave is moving. Second, the equation of wave. Okay? Here you are given the snapshot of the wave at t is equal to 0. Okay? So firstly, to get the direction of motion of the wave, we have the relationship between the particle velocity and the wave velocity. That is, dp, the particle velocity, is equal to minus v times slope of the curve at the point, dy over dx. Okay? This is actually the strain of the medium. So here the particle velocity is 20 root 3 and minus v dy over dx, that 1060. Okay? Or it is minus v root 3. This gives you v is equal to minus 20 centimeter per second. Okay? Now here as the minus sign, this indicates the wave is going along negative x direction. Okay? In the second part, we have to find the equation of wave. So finding the equation of wave, you have to find the initial phase. And supposing y is equal to a sine kx plus omega t plus phi. Okay? Now here is the plus because the wave is going along negative x direction. So to get the phi, we have the initial displacement 2 root 2. So we put here 2 root 2. This is 4 sine. This is 0 plus 0 plus phi. Or sine phi is equal to 1 upon root 2. Or phi is equal to pi by 4 or 3 pi by 4. Okay? Now for the next part, we need this value of frequency and the propagation constant. Okay? So to get it here, so this is the lambda by 2. So here lambda by 2 is equal to 3.5 minus 1.5, or lambda is equal to 2 times 1. This is actually 2. So it is 4 per centimeter. Okay? Now, finding the value of k, so propagation constant k barabar 2 pi upon lambda, so it will be 2 pi over 4. So it will, this is actually centimeter and this is pi by 2 per centimeter. Okay? Now the angular frequency omega, and omega is equal to 2 pi f. This is equal to 2 pi, and here the frequency, the f. The frequency is v upon lambda. So it will be 2 pi, v is 20 and lambda is 4. So it will be 10 pi radian per second. Okay? Okay? So now you put these values in this equation. So we have y is equal to, that's a is the amplitude of the wave, the 4 centimeter. Sine k, of got is pi by 2, so it is pi x by 2, and then plus omega 10 pi t, and the phase is plus pi by 4. Okay, thanks for watching the video.